So this is section 10.4 about ellipses. So once again, just like we've started every single section in Unit 10, we're going to start by refreshing your memory, making sure you know how to classify. Notice this time we don't even tell you what your options are. So again, think about whether there's one square or two squares, or I guess no squares. And then think about if you can tell if it's a parabola, circle, ellipse, or hyperbola. So again, pause the video, try it, just see if you're really getting it down. Hopefully you tried that on your own and checked it. And I do want to go back up just so that we don't forget what we learned about the parabolas. So on number 4, we said it's a parabola because there's only one squared term. But I'm curious, if it's the y that's being squared, is this the kind that's going to open up and down? Or is this the kind of the new kind that's going to open to the right or left? Hopefully you remember that if it's a y that's being squared, it's going to open either to the right or to the left. Again, depending on when it's in standard form, whether or not that y squared is positive or negative. I know right now it looks positive, but it's not in standard form either, so we don't know that for sure. Okay, so let's talk about how do we graph an ellipse. Well, ellipse is very similar to a circle in that there's a center, and the center tells you where on the graph it is. But notice on ellipse, I kind of have radius in air quotes here because it's not really a radius. If it were a single radius, then it would be a circle, right? Because if you went the same distance from the center all the way around, it would be a circle. So hopefully that kind of makes sense that really on an ellipse, there's going to be, I don't want to say more than one radius because radius implies the same distance from the center, but there's going to be one number that tells you how far to go left and right, and a different number that tells you how far to go up and down. And that's what's going to kind of elongate this and make it an ellipse as opposed to a circle. All right, so let's think about an ellipse. We know there are two square terms. So just like a circle, for the standard form, you're going to have an x minus h squared and a y minus k squared. So far it looks just like a circle, right? The center is still at the HK, just like on a circle. So the center is whatever the HK is, and you take the opposite of the number. But now I don't want to just say equals r squared because, again, then we're back to a circle. So the way we kind of show that an ellipse has kind of like two different numbers that represent the radius is we write it this way. I'm going to say all of the x's are over some squared number. I'm just going to call it a squared. It might be a 4, a 9, a 16, a 1. And then the y minus k. Now let's speculate. Would this be over a squared? Well, if it were, then wouldn't the x's and the y's have the same coefficient because they both would be over a squared? So this one is over some squared number, but it's a different squared number. And then we say the whole thing just equals 1. Now that's not a random number. That is 1, specifically and only the number 1. Okay, so this is what the standard form of an ellipse would look like. So the radius, again, I don't want to say there is two radius. Actually, what it's called a major axis and a minor axis, and the only difference is that one's longer than the other. So that's what they use instead of the idea of radius. I don't care that you know those words, but and it's going to come from whatever the A number is and the B number. Okay, so let me show you what I mean. Let's try this one over here first. Let's say I have x minus 2 squared over 9 plus y minus 1 squared over 4 equals 1. Okay, So I know that the center is at 2, 1, right? Because it's the opposite of those numbers on the inside. So the center is at 2, 1. All right, so look at the A number that's under the X's. It's a 9. Okay, so since that's a 9, that means the A number is 3. So in the left and right, and the reason I know it's left and right is because it's under the X's. So think about the X axis goes left and right. So for left and right, I'm going to go 3 units in each direction. That comes from the 9. And then notice under the Y's, there's a 4. So that's your B number. That's your B squared. So B would just be the square root of that, which is 2. So up and down, I go 2 units from the center. And so now when I draw this, it's going to look a little more oval than circular. It's a little bit skewed, right? Okay, let's try another one. Let's say on this one we have the equation x plus 1 squared over 16 plus y plus 2 squared over 1 equals 1. Now I know that normally if you have a fraction over 1, you don't write in the 1. So if there's nothing under it, you assume it to be a 1, like we have under the y's. So my center is going to be at, remember it's the opposite of those numbers, so my center is going to be at -1, -2. So let's see, -1, -2. In the A direction, so for the under the x's is a 16. So right and left, I'm going to go 4. Right and left, I'm going to go 4. That's coming from the 16 down there. Maybe I should color code it like I did. So because of the 16, that's how I know right and left. And then you say, well, under the y's, you have a 1. Well, what's the square root of 1? It's 1. So up and down, I have 1. So in this case, it's going to be this kind of long, skinny ellipse. Okay, for whatever reason, mine tend to look a little more. All right, I'm not an expert at drawing the ellipse, whatever. Okay, so again, just like the last homework, you got a section to classify, and then all of these are just practicing drawing ellipse. Okay, here's a situation where I give you the graph, so you have to think about where the center is, and you just kind of look in it, and you can tell where the center is, and then that's going to tell you how to write the equation. So again, don't forget, the equation is going to be x minus h squared over some a number plus y minus k squared. Remember that hk is the center. The a and the b's come from how far left, right, and up, down, and it's always equal to 1. So that'll give you kind of a pattern for writing the equation. And then notice on number 5, it's a circle. So you have to kind of remember back to what we did in the last section. So try those, and that should help you with ellipses.